Hey there, YouTube. Well, oh, sorry, give me a second here. We got a vastly windy day. 20 to 30 mile an hour winds with gusts over 30. I just wanted to show you something that I don't know if I've shown before. I don't think I have. This was one of the tests that I did with the HYE or high energy turbine. Freaking power cord is getting in my way. This was a test that they had asked me to do because I was having troubles with the turbine, and I did a couple of videos on it. I don't have the videos up anymore because it didn't get me anywhere, so I took them down. But this is a test that they wanted me to do, and I did. Okay, right now on the roof I have the WN750 mounted, installed, it's working. It's wired into these through a volt and amp meter, 75 millivolt shunt for the amp meter. The amp meter is 100 amp, volts 100 volts. Goes through a 150 amp, I think. Oop, she's getting a little warm. Yeah, just a 150 amps, 150 amp, 600 volt bridge rectifier. Okay, and I got a little heatsink on there, zip tied on there right now, but there's thermal paste on it, so it's doing what it needs to do. Anyway, they wanted me to hook up the turbine to battery bank, so I did. Okay, and these were the readings. I wouldn't even get these readings out of it. So I'm doing the same readings with this, or test with this turbine, except I'm not going over 24 volt. I got the 112 volt deep cycle battery, marine grade. It came out of a gem car, golf cart. Not really a golf cart, it's an electric car. So what I'm doing is I disconnected that inverter, the 500 watt, that's a 10 to 30 volt. And the top one is a 22 to 60 volt, 1000 watt. Right now, this one's unplugged. Here's a power cord for it, see? It's unplugged from the socket. And if you watch my other videos, you know how this setup works. It gets up over 24 volts, it activates a relay, which disconnects this one and only runs on this one for high wind power. Right now that one is not activated. It isn't powered up and it's on. I don't know if you see the little green lights blinking there, but it does have AC power. But it's, right now what I have set up is I got jumper cables coming from the positive and negative terminals on the side of the box that would normally hook up to this one. They go down into this 12 volt battery. Okay. 12 volt battery voltage is that. That's the amps going into it. It's slowing down, a little bit light wind right now. Well, we got some pretty nasty winds today. And I say nasty in a good way. Strong, gusty, steady. And right now, every time I come out here with this thing, the wind just dies right out. Every single time. But anyway, just to show you the kind of power that I'm getting out of, you know, it's essentially going through my wild AC lines here, through this rectifier, through these wires, through all the crap in the box, and they come out here. Right there. There's the negative side. Hook that back up. Yeah, I know. Don't do that. Don't do that. I just did. But whatever. Get this freaking cord out of my way. So it comes down that jumper cable right into that battery. And even with the light breeze, see, I'm pushing about 4 amps. 4 amps at it's about almost 14 volts. This battery is charging right now. I don't have any way of showing you wind right now because the Davis doesn't have any batteries in it. it's plugged in to the wall, and I just don't feel like really bringing it out here to show you wind speed. That's not what this video is about, but it's just to show that my system works. We have really strong wind today, and you're going to see here in a minute. You're going to see exactly what kind of wind we have. And this is the kind of wind I was testing the high turbine in, which it didn't produce. I wasn't expecting to see 20 amps at 12 volts out of it, but I was barely getting anything. This is the Windy Nation, and I'm getting a shitload of power. Alright, so now you're seeing it there at 12 volts. I'm gonna throw another battery on here for 24, so I will be right back. Okay, now I'm back. Now we got the same setup, except now we're on 24 volts. Two batteries. Two 12-volt batteries. They're identical makes, models, and voltage. Except this time now I got the 10 to 30 volt inverter hooked up, but it's disconnected from the internal system because of the 24 volts. So you can see here I'm up over 24 volts, almost 30 volts, and got a little bit of a low wind zone right now. Never fails. As soon as I turn the damn camera on, power just like drops. Okay, so 24 volts. We'll just watch the amps a little bit here. We can get enough wind now. There we go. See, this was the other thing I tried doing too. See, the high turbine is listed as a 48 volt turbine. Look at that. Look at that shit. And yeah, what was I saying? Oh yeah, the high turbine is a 20 or a 48 volt model. Okay? According to high. It would not do this. It would not do this. And then what I had done was I actually got in touch with High Energy and said I tried 12, I tried 24, I tried 36, and I even tried 48 volt. I even tried 5 12 volt batteries. Oh, my freaking math is just not working today. Is that 60 volts? Yeah. Whoa. Wow, it is freaking windy. Look at that. Holy shit. 40 volts, 40 amps. I'm glad I got that hooked up to battery banks. Okay, I'm gonna go see what that wind was because... No, you're coming with me. Okay, that was just... Okay, so here's the Davis. Yeah, see 30 mile an hour winds. Last 10-minute gust, that was 38 miles per hour. .39 was the 39 mile an hour gust. So yeah, good thing I had that hooked up, huh? Okay. Oh yeah, here's the time. That was just a few minutes ago I was out there. Okay, now we gotta get back out there and hook up the power before this dies out. Let's see, check it out. See? There's the software that runs on the computer all the time. I can watch the turbine with the camera. You can see how windy it is. See? Okay, we're going back outside. Okay, so now we're gonna do outside view. I don't know if you could hear or see that. is one badass wind turbine. Okay, now we're back in the garage. So there you go. That's what, you know, that would probably be close to 80 amps, 60 to 80 amps if it was the 12, just one battery. I'm really glad I got that hooked up, because I know what would have happened if it was just on the inverter. Probably would have jumped it out. 40 volts at 40 amps. That's 1600 watts. DC. Amps times volts. 4 times 4 is 16. 40 times 40 is 1600. 1600 watts. DC now. Okay? That's going directly into a battery bank. And you saw it was sustaining that for... Here, we're going to do it again. So, I mean, even 40 volts at 30 amps, you know, that's 1200 watts. This is a 750 watt turbine. And no, it does not have a furling tail fin. I'm torture testing this bad boy, and it seems to be working pretty well. So, this flipping thing works really, really good. Oh, I am very happy with this turbine. I think I might get another one. I think we might get another WN Ventura. Windy Nation. So, anybody that tells you that Windy Nation turbines don't produce, which no, I don't really see anybody ever saying that. You know, Windy Nation's a pretty quiet company, and I'd love to see you guys have a sale on one of these things. Even if it was just a generator head. But I'm thinking of actually trying the super amp model. This is the WN750 that's up there now. I may put the super amp model. That one's a 12 volt system, and that one does some pretty superior charging from what I see. But yeah, see here, I'll show you. There's no BS in this. There's the box. That is the ground side that comes out, and that's the one that goes into. That's the one that goes into the negative side of that inverter. Then daisy chains and goes into the negative side of that inverter. Okay. Then in the back there, that's the positive side that gets disconnected, which is disconnected right now. That goes into the 10 to 30 volt inverter. Okay, and then this positive terminal here, which is connected, goes up to that inverter. Remember, when this system hits 24 volts, it disconnects the 10 to 30 volt inverter. It's my own design. It's not something that I plan on trying to sell. Even though I could, but I don't want to. There's too much crap with wind. I don't want to get into it. I'd rather get into solar. But coming off of this ground side here, okay, coming off of that positive side for the 24 volt side. See, the batteries are back feeding into that, and that's why that relay is on. That's what that light means. The relay is active. That's why you're seeing like 30 volts and amps, low amps, and it's not fluctuating very much. But it comes directly out of that jumper cable, and it's just a jumper cable for a car. Jump starter wire goes right into battery, and there's the series connection. And you hear the juice bubbling up in there. So there you go. That's the WN750 at 24 volts. I should put it back down on 12 volts just for giggles and shits. Let me plug this. Oh yeah. See, and I have this unplugged too. Let me plug it back in so we're not unloading that turbine at all. See, what it'll do now is when I plug this back in, this will actually turn this inverter back on, and it'll actually start drawing from the battery pack too. But you won't see them amps because I'm on the other side of that. See how it's going crazy there? You can see. I'm making. Now that is only wind turbine power going into the batteries and into that inverter. So now I'm going to disconnect I'm going to disconnect this first. Okay. See, my batteries, or my wind turbine is always loaded up. See, that's going into the inverter now. Okay. Now we're going to go back to 12 volts. And we're going to go back to, let's go back to 12 volts here. Oh, that wire is loose. Okay, hold on a second. I have a problem. I got to fix this. So I got to shut the camera off. I'll be right back. Okay, we're back. See, now that's another good reason why you need to keep checking your electrical connections, because yeah, that's better. A lot of people don't realize it, but electricity vibrates, especially alternating current. It vibrates the wires. It's very, undetectable by the human body, but unless you grab it. Okay, so now what we're going to do is we're going to go back to ground, which is our common denominator here. So we're on the ground side there. Disconnect that there, and we're going to go to the positive side there. Okay, so now you can see I'm putting power in steadily. And the reason that's doing that is because that's on. We're going to disconnect this inverter. There it goes, it drops down. Okay. I'm on 12 volts on the battery bank. Now I got to wait for the turbine to slow down enough. Oop. Let's try this here. Here we go. It's never gonna, not with these ones, it's never gonna slow down enough. Okay, hang on a second. Oh, there we go. Okay. Now, there's our voltage, there's our amperage. Now we're on 12 volts. 12 volt, see? They're still hooked up in series, but they're only connected as, I'm only using one battery on the jumpers. So there you go. That is awesome. I really don't want to dump 80 amps into that one battery, because then it'd be like boiling it. The bridgeum rectifier is a little warm. I know my 6-gauge wire coming off the turbine's not hot. It's warm, but it's not hot. Only at the rectifier though. But that's heat transference coming from the rectifier to the wire, and it's only right out the terminals. So let's see if we can get one more blasty here, and then I'm gonna edit this video up, splice all these connections together, and get this video uploaded. Hear the damn thing jiggling up there. I gotta tighten my guy wires too. All this wind, and like I said, it's been so cold, I don't want to get up there and do it. The roof is covered in snow. I'm not getting on the roof with snow on it, especially with the layer of ice that's underneath it. But it's been really warm this yesterday, and today it's been really nice, so I'll make a valid effort to get up there. I gotta get out here and get this place cleaned up too. The spring's coming and business will be starting up soon. I'll start getting all my stuff together and get back on the mobile golf cart repair. But remember, like I said, that one is plugged in. This one is not. I am actually connected directly to the battery. 12 volts. A nice big gust. Hope I don't get another 40-mile-an-hour wind here. But that's it. I mean, that's the update. There's no real change. It's been too cold to be out here. I still got 500 watts in solar panels I got to get up. There we go. See what this does. And I don't have a charge controller on these batteries. This is straight 2. Oh my god, I can't hold this up anymore. This is straight 2. And I'm out here only for this little bit to... I mean, there's... 4 or 5... 400 watts. See if I can hit it at 12 volts. It's easy to hit high watts at high volts and high amps because you get them RPMs up, and once you get them up there it's easy to maintain it. But when you have low RPMs and low voltage and high amperage, it's kind of hard to maintain that. That's why I like 12 volt systems, because everything is 12 volt really. Like if you need to run off your vehicle electrical system, you can run your alternator in your car and run a small inverter that way if, you know, emergency need. But I also like 24 volt systems for the efficiency. They're a little bit more efficient than 12 volt, especially when it comes to running inverters. When you get up over 2,000 watts, it's 3,000 watts even. You get up over 3,000 watts, that's a good idea to go 24 volts if you have the capabilities. Like the solar panels I got, they're 18 volts each, but I'm going to series parallel them and make them 24 volt, and they're 100 watts each. I got 5 of them. I got them when Windy Nation was having their sale. God, I hope you guys have that sale again. That was awesome, because I'll order 4 more. And I bought one way back in the day to try, and it worked. It worked really well, but I don't have any way of mounting it right at this moment, so that's why I don't have it hooked up. And this wind would just destroy it. That was almost 800 watts. Wow, it is freaking windy out there. I don't know if you can hear it. It's shaking the hell out of the garage. Come on. Come on, 40 amps. Ba-chan, one more. Yeah, there you go. Oh, almost 50 amps. Almost 1,000 watts. I mean, it's not steadily. If I had 40-mile-an-hour winds all day today, I'd be easily hitting that. But, you know, that's just the way it is. Now, it's not a constant 1,000 watts or 1,600 watts like I hit before. Well, it was a little bit steady for a little while, for a couple of seconds at least. But knowing that this turbine will hit that and it's not even rated for that high of a power output, I more than doubled its power output. Or I saw more than double its rated power output. That is awesome. So, but that's the quick and dirty. I'm gonna hook this back up to the inverter so I can enjoy this. Going back, oh, let's see. It's supposed to be like this all day today and tomorrow. Yay. Okay. Alright, YouTube. We'll be in touch.